gap is closing. American complacency is the greatest threat. Who will dominate the underwater domain in 20 years?
If we adjust the aft section geometry, we reduce cavitation.
What about the stability impact during launch?
The acoustic signature remains minimal, confirming stealth capabilities.
Excellent. The warhead simulation shows successful deployment.
Look at the stress analysis on the propulsion unit mount.
It won't hold during the transonic phase.
We need to reinforce the guidance section structure then.
The tolerance diagrams align with the schematic updates.
The analysis confirms it.
Stamping approved.
Transition from virtual to tangible manufacturing is secure.
Absolutely. Let's get these signed and start production.
Watch that turn, Bill. Bring the titanium over here.
Copy that. Is Bay 3 clear for the steel plates?
All right, bring it down slow. Watch the clearance on the right. Easy now, almost there. Set it down. Check the alignment on station 3.
The chips are clearing properly now.
Increase the RPMs on the center spindle.
Flawless penetration confirmed on the ultrasound.
X-ray confirms integrity.
This section is cleared. The readings are optimal.
Agreed. Moving on.
Maintain vacuum pressure for another 30 seconds.
Resins are stabilizing. Sonar transparency looks good.
Digital signal processing hardware, interpreting sonar echoes, discriminating targets from noise, calculating intercept solutions, computing power for underwater decisions.
Guidance integration mounts electronics in shock-isolated frames. The Torpedo experiences extreme acceleration at launch. Electronics must survive to function. Functional testing verifies every circuit, every algorithm. Simulated sonar returns test target acquisition. Simulated commands test response. Perfect function required.
Higher guidance spool tapped miles of thin cable, allowing the launching submarine to send commands and receive data. The umbilical connection between weapon and shooter.
Propulsion section hub, where the torpedo's power is created.
fuel storage, engine components, the systems that drive the weapon at 50 fuel tank construction crate containing hundreds of liters of specialized propellant. Auto fuel, the monopropellant that enables underwater propulsion, or thermal alternatives.
Auto Fuel 2 a monopropellant containing its own oxidizer.
Fuel handling requires specialized safety procedures. Auto fuel is toxic fungus, protective equipment mandatory, emergency procedures rehearsed.
Engine manufacturing Sapphires, the swash plate cam engine that converts fuel energy to rotation. Pistons, swash
engine components machined to aerospace tolerances. Each piston, each valve, each bearing surface, perfection required for the thousands of cycles at full power. Engine assembly by the most skilled technicians. Each component installed to specification. Each fastener torqued precisely. The power plant taking shape.
Engine testing at full power, verifying horsepower output, fuel consumption, operating temperature. The engine must
the pump jet propulsor, replacing traditional propellers with shrouded impeller. Quieter operation, higher efficiency, reduced cavitation. Stealth through engineering.
Propulsor components, stator vanes guiding flow, rotor blades providing thrust, shroud containing everything. Each blade shape optimized for efficiency and silence.
Propulsor assembly, each blade installed at precise angle, rotor balanced to eliminate vibration. An unbalanced propulsor creates noise that reveals the weapon. Propulsion integration connects engine to propulsor. Fuel system, control valves, power transmission plus, all joined into cohesive propulsion unit.
Warhead manufacturing is in a separate, highly secured facility. Explosive materials demand extreme care.
Modern torpedo warheads use insensitive high explosives, Pegasus PBXNs 103 or similar.
Explosive loading under strictest procedures. Remote operations where possible. Minimal personnel exposure. One mistake could be catastrophic.
Fuse manufacturing bench, the component that decides when to detonate. Contact fuses, proximity fuses, programmable options. Arm when commanded, fire when required, safe otherwise.
Safe and arm devices with multiple interlocks. The warhead cannot detonate until commanded, cannot arm until launched, cannot fire until conditions are met. Safety through redundancy.
Warhead integration joins explosive to fuse, case to electronics. The killing mechanism complete, awaiting installation in the torpedo body. Control surfaces, the fins that steer the torpedo. Precise shapes for hydrodynamic efficiency. Actuator mounts for powered movement. Maneuverability for the kill. Actuators that move control surfaces, responding to guidance commands in milliseconds. Electric or hydraulic servos, high power density, extreme reliability.
Control system electronics powers Polysym, the autopilot that maintains depth, heading, speed. Sensors measuring attitude, algorithm.
Final assembly 2, where all sections become one weapon. The moment when thousands of components, months of manufacturing, come together.
Guidance section slides into forward hull. Electrical connections made. Mounting hardware torqued. The torpedo's brain in its protective skull. Warhead installation, always with explosive safety procedures. The killing mechanism joining the thinking mechanism. Purpose meeting intelligence.
Propulsion section joins mind as fuel tanks, engine, all the power systems. The torpedo gaining its speed, its range, its ability to chase down targets.
Propulsor installation, the quiet thrust system mounted at the tail. The torpedo now capable of converting fuel to motion, of chasing targets at 55+ knots. Electrical integration connects every system. Power distribution, signal paths, redundant connections.
Hull sections joined with precision fasteners, O-ring seals preventing water intrusion. Each connection designed for the crushing pressures of deep operation.
Control surfaces mounted plea, the fins that will guide the weapon to its target. Actuators connected, movement range verified, maneuverability enabled. External inspection checks surface quality. No protrusions to create drag, no gaps to allow water intrusion.
Weight and balance verification. The torpedo must be neutrally buoyant, center of gravity precisely located.
Assembly complete. 21 feet of integrated systems, thousands of components working as one. But assembly is not complete.
Testing begins with the most rigorous verification program in defense manufacturing. Every system tested individually. Functional testing checks every electronic system. Guidance responds to simulated targets. Control surfaces move on command. Propulsion controls function correctly.
Environmental testing subjects the torpedo to extremes. Arctic cold, tropical heat, the thermal shock of launch. The weapon must function in any ocean.
Cold testing to 20 degrees Celsius simulates Arctic operations. Every system must start, every seal must hold, every lubricants.
Heat testing to +50 degrees Celsius simulates tool storage and Persian functions. Electronics must
Shocking set simulates nearby explosion. Depth charges. The torpedo reported and settled.
Acoustic testing in anechoic chamber measures noise. Every source of sound identified, every vibration characterized. Quiet torpedoes reach targets alive. Noise sources identified and reduced. Bearing refinement, vibration isolation, flow optimization. Each decibel of reduction increases the weapon's lethality.
Complete pressure testing by the assembled torpedo subjected to depth pressure. Not just the hull, but seals.
Pressure increases to simulate maximum operating depth, minus 3,000 feet, over 90 atmospheres. Guidance calibration aligns sonar precisely to torpedo axis. Errors in alignment become errors in targeting.
Software loading installs the latest guidance algorithms. Classified code, regularly updated, representing the latest in target motion analysis and countermeasure rejection.
Propulsion run-in brakes and new engines. Controlled operation wearing and moving parts, establishing baseline performance. Each engine characterized before installation.
Fuel system testing verifies pressure, flow, leak-free operation. The toxic auto fuel requiring perfect containment. No leaks accepted. Every test documented too, thousands of data points recorded, analyzed, archived. The torpedo's complete history available for any future question. Any test failure triggers investigation. Root cause identified, corrected, retested. Some failures require rework, some require rejection. Factory testing complete, open water trials begin. The torpedo will finally enter its intended environment, the ocean that it's designed to master.
Test range, specialized naval facility with tracking systems, recovery vessels, safety boats, where torpedoes prove themselves in real conditions.
For water trials, warhead replaced with exercise section, minus data recorders instead of explosives. The torpedo will be recovered, its performance analyzed.
Test launch, the moment of truth. Compressed air or swim-out launch sends the torpedo into the sea. Tracking systems following every movement.
Underwater flight at full speed, propulsion performing, guidance acquiring practice targets, control surfaces steering. The weapon demonstrating its capability.
Target acquisition test, the torpedo finding and tracking practice targets. Guidance algorithms proven in real water, real acoustics, real conditions.
Size recovery retrieves the torpedo for data download. Every sensor reading, every command, every response, analyzed for performance verification.
occasionally, warshot tests with live warheads against target ships, verifying that the weapon does what it's designed to do. Destroy.
Test data analysis compares actual performance to specifications. Speed achieved, range demonstrated, guidance accuracy verified, numbers proving capability.
Formal acceptance, the government customer verifying that specifications are met. Sign-off representing thousands of hours of work, millions of dollars invested.
Final preparation for fleet delivery. Exercise section replaced with warhead, all systems verified one final time. The weapon ready for service.
Final finish applied corrosion protection, identification markings, serial numbers. The torpedo's appearance reflecting its deadly purpose.
Documentation accompanies each torpedo. Complete history, maintenance procedures, performance data. The paperwork that follows the weapon through service. Protective storage containers preserve the weapon during shipping and storage. Climate-controlled, shock-protected, the torpedo secure until needed. Quality management encompasses every step. ISO standards, military specifications, continuous improvement.
Supplier management ensures quality components. Vendors certified, audited, monitored. The supply chain as critical as the factory itself.
Traceability tracks every component. If any part fails in service, its entire history is available. Lessons learned applied to prevent recurrence. Continuous improvement makes each torpedo better than the last. Process refinements, design updates, lessons from missions. The workforce pedal, engineers, technicians, inspectors, kuni, the humans whose skill creates these weapons.
Training programs develop skills over years. Apprentices becoming journeymen, journeymen becoming masters. Knowledge passed generation to generation.
Originals. Kaitrulan, the complete timeline. Design 6 to 12 months, procurement 3 to 6 months, hull fabrication 4 to 6.
Total time, 18 to 24 months from order to delivered weapon. Cost breakdown. Materials 30%, manufacturing labor 25%, testing 15%, guidance electronics 20%.
Total cost, $3 million or more per weapon.
Production rates. A single facility might produce dozens to hundreds of torpedoes per year, enough to meet peacetime needs, scalable for wartime demand.
Fleet delivery distributes torpedoes to submarine bases worldwide. The weapons dispersed, available where needed, ready for loading.
Base storage maintains torpedoes ready for loading. Climate-controlled magazines, regular maintenance checks, the weapons awaiting their submarines. Torpedoes require periodic maintenance, batteries replaced, propellants refreshed, guidance updated. The weapon maintained through decades of service. Upgrade programs install improved guidance, new software, enhanced capabilities. The same torpedo becoming more lethal as technology advances. Service life, 20 to 30 years with proper maintenance and upgrades. The torpedo manufactured today will threaten enemies for decades. Eventually, retirement. Warheads demilitarized, components recycled or disposed. The weapon's service complete, its mission fulfilled. Even as torpedoes enter service, next-generation development begins. The cycle continuing, each generation more capable than the last.
Torpedo manufacturing is critical defense capability. The facilities, workforce, supply chains, national assets requiring protection and investment. Often, single-source manufacturing creates vulnerability. One facility, one supplier solutions. If disrupted, the fleet wartime surge capability maintained, the ability to rapidly increase production when conflict demands, peacetime efficiency balanced against wartime necessity.
Global competition drives improvement. American, Russian, Chinese, European manufacturers all racing. The competition improving all participants.
Manufacturing technology carefully protected. Export controls, classification, security clearances, toppers preventing adversaries from copying capability.
The torpedo factory toad, where physics becomes weapon, where engineering becomes lethality.
Precision, the constant theme. From raw material to finished weapon, precision at every step. Tolerances measured in thousands, performance measured in kills. Integration, the critical challenge. Thousands of components becoming one weapon. Each system supporting others, all working towards single purpose.
Testing, the constant verification. Nothing assumed, everything proven. The testing that ensures the weapon performs when lives depend on it.
The human element. Skilled workers taking pride in creating weapons that protect their nation. Dedication that no machine can replace. From concept to approved design, 6 to 12 months. The intellectual foundation for everything that follows. Engineering excellence on paper. Materials procured and inspected minus 3 to 6 months. The raw materials that will become titanium hulls, copper electronics, explosive power.
Hull fabrication complete, 4 to 6 months. The pressure vessel that will protect all internal systems at crushing depths.
Components manufactured, 8 to 12 months. Guidance, propulsion, warhead, control, all the pieces ready for assembly.
Assembly complete minus 2 to 3 months. Thousands of components, now one weapon. The torpedo taking final form.
Testing complete minus 2 to 4 months. Every system verified, every specification confirmed. The weapon proven, ready.
Delivered, 18 to 24 months total. From blank paper to deadly weapon. The manufacturing journey complete. The manufacturing summary. Design, procurement, hull, components, assembly, testing, delivery. The complexity. Thousands of individual parts, millions of manufacturing operations, hundreds of skilled work.
The technology level, aerospace-grade manufacturing, defense-grade security, precision-grade quality. Only advanced nations can build heavyweight torpedoes.
Investment, billions for facilities, years for workforce training, decades for experience. Torpedo manufacturing capability not created quickly. Continuous production maintains capability. Workforce skills, supplier relationships, production efficiency tune all require constant exercise to remain sharp.
Manufacturing evolves continuously. New materials, new processes, new technologies, food, the factory future manufacturing, additive manufacturing, advanced composites, AI-assisted quality control. From blueprint to ocean, the complete journey of heavyweight torpedo manufacturing. Engineering, precision,
design pretty, where concepts become specifications, where requirements become reality on paper.
Materials blueprint, titanium and steel, copper and explosive, the raw materials of underwater warfare.
Fabrication titles, CNC precision, electron beam welding, pressure testing, the hull taking shape.
Components myron, guidance, propulsion, warhead, control, thousands of parts precisely manufactured. Assembly priorins, sections joining, systems integrating, the weapon becoming whole. Testing crew, environmental, functional, water trials, proving every capability.
The complete weapon, 18 to 24 months of work, millions of dollars invested, ready to perform in seconds.
Launch ready, Tor, and the Torpedo awaiting command. All systems active, target acquired. The manufacturing investment about to prove its value.
Launched X, compressed air or swim out, the Torpedo entering its domain. 21 feet of precision engineering beginning its mission.
Tintist, guidance seeking, propulsion driving, control surfaces steering. Every manufactured component working together toward the kill. Impact, 650 pounds of precisely manufactured explosive delivering destruction. The purpose of every manufacturing step fulfilled.
From blueprint to ocean keel, 18 to 24 months, $3+ million.